Solutions. Solutions have part solute and part solvent. I spelled this here. So solvent is when you have something that dissolves the solute, and the solute is what is being dissolved. Molarity refers to concentration. It's the number of moles of solute per 1 liter of solution. How to solve? Molarity equals number of moles divided by volume of the solution. And number of moles, remember, is the mass divided by the molar mass of that compound. Dilutions, remember that molarity equals moles divided by volume. Okay, so here's our equation here. Molarity times volume 1 equals molarity 2 times volume 2. Dilutions means you are watering that substance down. But in actuality, what's happening is the number of moles stays constant. So as the volume increases, the molarity decreases. So we can say that there's an inverse relationship between molarity and volume. An acid is a solution with a lot of H plus ions, and a base we know is a solution with a lot of OH minus ions in solution. pH, remember, is the measure of H plus ions, and pOH is a measure of concentration of OH minus ions. When we calculate the pH, if the pH is greater than 7, that means it's a base, which means that there's less H plus ions and greater numbers of OH minus ions in solution. An acid, remember, has a pH of less than 7, which means we have a greater concentration of H plus ions than we do hydroxide or OH minus ions. And a neutral solution, remember, has a pH of 7. And that just means that the concentration of H plus ions is equal to the concentration of OH minus ions. We have all these different calculations in order to calculate all these different numbers. So remember that pH plus pOH equals 14. How do we calculate pH? Well, we need the concentration of H plus ions, and we're going to take the negative log of it. Or if we go the other way, if we have the pH and we want the concentration of H plus ions, we're going to go 10 to the negative exponent of pH. The same is true for pOH. pOH, remember, has to do with the hydroxide ion concentration and how to calculate that. Going from hydroxide concentration to pOH, we take the negative log of the hydroxide concentration, or if we have pOH and we want the hydroxide concentration, we go 10 to the exponent negative pOH. There's two more equations. Remember that pH plus pOH equals 14, and if we're given these concentrations, we can find one or the other by dividing it simply by 1 times 10 to the negative 14. Final thing has to do with titrations. Titrations has to do with finding an unknown molarity, either the molarity of an acid or the molarity of a base. Okay? Now remember, molarity times volume equals moles. So when we titrate, we're basically getting equal numbers of moles of A and moles of B, and that's what we call the equivalence point. When we find that equivalence point, that just means that the concentration of H plus ions equals the hydroxide ion concentrations. And we do that by using what we call indicators. Okay? And when the indicator changes color, that denotes that we have reached the equivalence point, which is a pH of 7.